and today we are going to discuss about an easy machine learning algorithm. It's called linear regression, and we will try to build an end-to-end linear regression algorithm. So we will try to understand how they have implemented the fit predict methods inside the algorithm, and try to test it with our scikit-learn model to see how our prediction looks compared to the scikit model. Before we get in, I wanted to give some brief about what linear regression model is. It was, I believe, one of the first machine learning models, and the main concept from the name itself we could understand. One is linear, so the idea is it's trying to plot a line through our data, and let's see here, something like this, so that based on this, whenever it sees a new value, it can predict what could be the outcome, right? For example, in our case, we are trying to take the example of a housing price. So if it sees a new housing area, it's able to predict the new price based on this line which it draws. So the entire idea of this algorithm is to figure out where the line should be drawn, right? And that is linear, and regression is a way of predicting numbers. So there are two types of supervised learning. In one case, we are trying to predict different categories, and if it is predicting numbers, it's called linear regression. Okay, so for any line, the formula is y is wx plus b, where w is the weight and b is the bias. So at the end, we should get a value of w and b, which can be used to draw the line and make future predictions. Now there are two types of linear regression, if you will. One is with only one set of features, so we are, for example, only taking the house area, right? And when we say multi linear regression, there would be a lot more other features like the number of rooms, maybe the square feet, then some other details also about the house, the location and other stuffs, right? But the concept overall is same. So let's first try to implement a simple linear regression. So I'm going to upload this code anyway in GitHub. However, this is the final output function which we are going to test it with this Jupyter notebook. So first let's try to implement this, right? So there are mainly 5 methods. The first one is the init one. So you are trying to initialize the value. Okay, so initially we may set both w and b to zeros. So let's see, self dot w equal to init of w. Then we need self of b, and let's initialize it to init of b. That's so from the program, if you see, you will first call the fit method. So let's see an example of the actual scikit linear regression. So scikit is a library which implements a lot of machine learning algorithm. So if you were using their linear regression, the first thing you will do is call a fit method, right? And you will pass the x and the y. So the same thing here, we will have a fit method and we are passing x and y. Now here we are also taking few more arguments which scikit would be handling internally, but the general idea is same. We have a fit method where we want to iterate through, so let's say for iterate, epoch is the number of times you want to iterate and keep learning, right? So if you want to iterate maybe 1,000 times, it's going to take this much amount of time, and if your model has not learned much, you can increase that to 10,000 times and others, right? And LR is the learning rate, that we will come to afterwards. So first we understand that we have to iterate across, right? So for I in range of epochs, what we are going to first do is let's calculate the gradient. So we will have a gradient at a cost. Later we are going to implement that. So first, okay, let's think about the cost, right? Cost is equal to cost function, and what it needs is to compute a cost. So cost is if you could, right, we are trying to make a prediction for this guy. So it's so far from the line, right? So this is the cost, right? And we use something called mean square error cost. Okay, so we need x, which you'll get from argument y, and self of w and self of b. So that way we got our cost. The second part is our gradient we have to compute. So gradient is, imagine first we see the cost is very high, right? We have to try to reduce the cost, and this is a good demonstration of that. Initially the cost was very high and we are trying to reduce the cost. So gradient descent is the way we are trying to reduce the cost. So for that we want the derivatives of w and b, or the small step w and b has to take to reduce the cost, right? So compute gradient x, y, w and b. So once we calculate these values, we have to then update our self of w, right? That is where the learning rate comes into picture. We want to take decide how much we want to update w based on the learning rate. So self of w equal to self of w minus, so we are reducing learning rate into derivative of w. Okay, same thing for b, self of b minus lr into derivative of b. Now that is how we are going to do the fit or train the model. Similarly, if you see, finally once you train it, you do a predict, in which we will use that w and b which has been fitted or learned, and we're going to make a prediction. So that would be y is equal to self w into x plus b, right? Or self of b. Now once that is calculated, let's go to the cost function. So I believe we have two things to do. One is cost function and compute the gradient. So cost, as we said, it's the mean square error we are take. So for that, first m is length of x. This is how many number of data we are trying to get. So let's see our data first. So we have simple housing data set, right? So this is the area and this is the price. So similarly we have 101 records, right? So it's going to iterate 101 records and try to find the cost. So what would be our cost? Cost sum, let's initialize it to 0. Then for I in range of m, we're trying to iterate, and first we are trying to make a prediction with the existing w and b. So y pred equal to the same thing what we do here, self okay, we got the w here, so w into x plus b. Now we have a prediction, we want to see the error of prediction, right? So that's where our cost is. That would be y prediction versus the actual value of y. And because I said it's a mean square error, we have to multiply by, take the square. Finally, we are going to add the cost to the main cost sum is equal to cost sum plus cost. And once you have the cost, the total cost equal to 1 divided by, because we are iterating m number of times, we have to multiply by that, and 2 is used to make this computation easier. So basically, because you are taking a mean square, and then you're going to multiply the cost sum. But basically we are trying to find the total cost and return from this function. Similarly, we are going to compute the gradient, but remember, in gradient we are trying to find what is the small step w and b has to take to reduce the cost, right? So similarly, m is equal to ln of x. Alright, and here dl dw is the derivative of w, dl db is the derivative of 0, and for I in range of m, we're saying first let's get the y predict equal to w into x plus b, and this time you want to find dl dw of I in this first step. That is similar to the cost. We are trying to say y predict minus the actual y into x of I. Basically the derivative of w, because it is dependent on x, we have to multiply with x of I. Similarly, dl db of I we are trying to find, but at this time b doesn't depend on x, so the formula doesn't have x. The derivative part, how it is computed, maybe you can learn more, but to understand how this works, we are not going into details of that. So dlw is equal to dl dw plus dl dw of I. Similarly, dl db equal to dl db plus dl db of I. Finally, we have to divide, because we are iterating m number of times. We dl dw by m. Similarly, dl db is equal to dl db by m, and we are going to return dl dw comma dl db. This is how we compute the cost, and with that we have the basic simple linear regression implementation. So now we could see how this all works. We are using pandas to load our data set, which we recently saw. It has area and price, and let's try to train a scikit-learn linear regression. Okay, first we have to run this. So it created a linear regression model that we are saying SK model because it's a scikit model. Now with our simple linear regression, we are trying to create our model. So here you can see it trying to train. We gave 1000 times, so it's iterating and its cost is reducing, right? Finally, we are trying to print the weight and the biases using both our model as well as scikit model. And you could see it's almost same, so our learning algorithm could also figure out a similar value for weight and bias. Now let's also try to make a prediction. We are trying to predict the price when the area is 9000, and both of them predicted almost similarly. That means our learning algorithm also was implemented correctly. So let's also try to plot it. That's the same plot we saw previously, and this is how the course looks, right? So this is all about a simple linear regression. I have also implemented with multiple linear regression where you have more than one features. So feel free to check out the GitHub repository, and thank you.